Okay, this is going to be our last example. Find the tangent of 225. So very similarly, I am going to start by drawing in my angle. 225, let me label some stuff. I know this is 0 degrees. I know this one's 90. This one's 180. Down here, 180 plus 90, that's 270. Okay, 225. Where is that gonna lie? Well, let's do some math on the side over here. 225 minus 180, and we get an extra 45 degrees from 180. I'm going to try and make this a little bit straighter. Okay. So here's our angle measure. I can't even draw a nice curve. Here's our angle measure. But here's the thing that I want to point out. You'll notice that we haven't done these angles over here. We haven't done anything to the y-axis. And the reason being, the y-axis is not what we want to use. We want to use the angle made closest to the x-axis, never the y-axis. So in case you forgot, x-axis is totally horizontal and the y-axis is totally vertical. Okay? So that's why we've been doing our perpendicular line from the terminal side down to the x-axis, because this is the angle we want to use. That's 45 degrees more than 180. And that's going to come in handy. That's why we've been doing it, because we want the angle that's closest to the x-axis so that we can actually find our trig functions. I think this makes a lot more sense now that I've explained this a little bit more thoroughly in the third example. I'm sorry that's taken me so long to get to this. I thought it was straightforward. That's probably my thinking and my mentality. But hopefully that makes a lot more sense as to why we've been using this angle right here when we start doing all of our labeling. Because that's the angle we absolutely need in order for us to even create the triangle. So now let's create our triangle here. This is nowhere near perfect. In fact, I am going to try and fix that so that's a little bit straighter. There we go. That's probably like my nicest triangle I've made all day. Okay, this is obviously not perfect, but I'm okay with that. This is a 45, 45, 90 triangle after we've made those, so let's determine our side lengths. We're on the negative part of the x-axis over here. So instead of it being a positive 1, let's make it a negative 1. This value is following the negative part of the y-axis. So let's also make that a negative 1. Now let's do some math over here. Negative 1 squared plus negative 1 squared. Will that still give me square root of 2 squared? Okay, negative 1 times negative 1 is 1. We get that twice. What happens here? Well, those will cancel out and we're left with 2. So the question is, does 1 plus 1 equal 2? It does. So square root of 2 is good to stay there. You'll notice that our hypotenuse value is not negative because of the Pythagorean theorem that we just did. Okay, this is because I already knew the values for the 45, 45, 90. But even if you didn't, you'd still end up with the exact same thing. Promise. Try it. Okay. If we're using this angle, this is the opposite. This is the adjacent. This is the hypotenuse. Alright, let's remember our acronym. SOHCAHTOA. Okay, so tangent uses the opposite and the adjacent. That's very, very helpful, okay? So tangent uses the opposite over the adjacent. So my opposite is -1. My adjacent is -1. -1 divided by -1 is a +1. And so that would be my tangent. So now that I've done an example for both sine, cosine, and tangent, I honestly feel like you should be able to identify which triangles you use on the coordinate plane, and you should be able to find any sine, cosine, or tangent function based off of these 3 examples. I'm going to wish you the best of luck getting through all of this, and make sure that you do the interactive activity. It will be beneficial. I promise. Good luck!